Today we're talking about literal equations. A literal equation is an equation that has more than one variable. So you have dealt with them before. We dealt with them in Algebra 1 when we were working with equations in standard form and we had to solve for y. You've dealt with them in geometry. Anytime you've worked with a formula and isolated a variable, that's a literal equation. So in general, as we're working through this unit, we want to put all terms with the indicated variable, the variable we're solving for, on one side of the equation. We're going to move everything else to the other side. We are using our operations. To undo addition, we're going to subtract. To undo multiplication, we're going to divide, and so on and so forth. So we are using that knowledge base of solving equations in this unit. And then do the algebra to isolate the variable. When you're done, you should only have the indicated variable on one side of the equation and only one copy of it. You shouldn't see the indicated variable anywhere else in your solution. So in this example, we want to solve for y. That means we should move the y terms to the same side of the equation. All right, so I'm going to choose to move the y's to the left-hand side of the equation and move everything else to the right-hand side of the equation. In order to move the y, I'm going to subtract from both sides, being mindful of like terms and little things such as the coefficient here is 1. So technically I'm subtracting 1y. My like terms, this would end up being 4y. And then I'm going to move the 3x to the other side because it should move away from the y side. Again, like mindful of like terms. This combination would be 5x. Copy anything you didn't touch. We are looking at 4y equals 6 minus 5x. Although there is only one copy of y in this equation, we haven't quite solved it fully yet. It's not isolated. We're going to divide every term of the equation by 4. Divide by 4, divide by 4 to fully isolate that y. Now, we can do it this way, where we divide each term separately and we simplify, getting us a solution of y equals 3 over 2 minus 5 over 4x. Or you could do it as one division without simplifying. So your other option really would be y equals 6 minus 5x over 4. These are equivalent forms. We really don't care which one you choose. The thing to be careful with is the solution on the right-hand side, this one right here. We can't simplify the 6 and the 4 because the 5 doesn't have a 2 in common. So it just have to stay the way it is right there. In our second example for today, we want to solve for w. So we're going to take a minute, move some terms around using addition and subtraction. I'm going to get all my w's on the left-hand side and everything else on the right-hand side. I just like to put the variable I'm solving for on the left-hand side. It's a me thing. It's really your choice, though. So the commutative property of multiplication does allow me to change that 2yx to be 2xy, matching those terms, allowing me to add the like terms. Now, if you notice here, we have a w, which is our variable in question in both terms, but those are not like terms. Now, if you notice here, we do have our w, which is our indicated variable, the one we want to isolate, in two different terms. But they aren't like terms. There's no way to combine those to make it just one term on that side. So we are actually going to use our distributive property to rewrite that with only one w. So if we kind of undistribute or factor out, if you will, we notice that we can write the equivalent form of the left-hand side as a distribution problem. There's only one w here and it's being multiplied to the parentheses. Now I know how to work with a multiplication statement. Therefore, I can get that one w alone. That factoring out or that undistributing isn't going to affect my right-hand side. In order to isolate the w, I'm simply going to divide both sides by what's in the parentheses. The whole thing. You can use parentheses if you want to. In this case, because it's just going in the denominator, you really don't need to. And you don't have to simplify that division statement at all. Your final answer can be w equals 4 minus 4xy over 3x plus y. So if you have a variable that's indicated that you're solving for in more than one term, you do have to apply the distributive property in the opposite way, which we call factoring out in algebra. That is all for our conversation on literal equations today.